Thank you for joining us in this presentation, introducing the W77Q Secure Flash Memory. Here at Winbond, we are very excited to introduce the W77Q. It is our third generation of secure flash memories, presenting a new approach for IoT security. This presentation focuses on platform firmware security, with secure firmware updates, secure firmware storage, and secure boot. This presentation is followed by additional presentations covering other key features and topics related to the W77Q. Platform firmware must be secured throughout its entire lifecycle, including the ability to securely update, store, and execute the firmware. The W77Q supports this with the secure firmware update, secure firmware storage, and secure boot functions. Secure firmware update is essential for keeping IoT systems secure by resolving known vulnerabilities and keeping the system up to date. The W77Q introduces a new approach for secure over-the-air firmware update. In the traditional approach for firmware update, an update authority, such as a cloud service, would generate a firmware update package. The MPU of each system that receives the package verifies its authenticity and updates the flash memory. The MPU executes the security function, authenticating the new firmware. So the assumption is that the MPU must be secure. This assumption is self-contradicting, as the firmware update may be needed because a vulnerability was found in the first place. To work around this contradiction, traditional solutions are often based on an independent component, such as secure element or other trusted environments. These solutions typically involve complex code and may require changes to software architecture. They also require valuable expertise and design effort, and defocus vendors from their core competencies. The W77Q introduces a new approach for secure firmware update, where the local MPU is not part of the security function. This is done using an end-to-end secure channel and a full rollback protection function within the flash memory. Access to the W77Q secure functions is possible via the end-to-end secure channel, allowing end-to-end logically secured data transfer. Data is encrypted, authenticated, and replay protected using a unique single-use key. The secure channel is established directly between the remote update authority and the W77Q. The local MPU does not execute any secure function. Therefore, the operation remains secure even if the MPU is compromised. Furthermore, the MPU does not have the keys or privileges to modify the firmware stored on the W77Q. This reduces the surface of attack. It is important to clarify that the W77Q is a purely hardware solution, with hardware implementation of its security functions resulting in a cost-effective solution. The rollback protection function was described in part 1 of this presentation and mentioned here for the completeness of this discussion. Once the entire new firmware is written to the W77Q, it is committed. The W77Q accepts the committed code only if it is authenticated, and its version tag is newer than the version tag of the older firmware stored in the flash memory. This is done by the internal rollback protection function in a single atomic failsafe operation, making it ideal for remote over-the-air firmware update. Once new code is committed, it is also locked by the W77Q cryptographic write protection function, thus assuring it is not changed from its authentic state. After firmware is loaded into the system, it must be stored securely. The W77Q supports direct code fetch, which facilitates execution in place, so code could be executed directly from flash with no need for code shadowing, thus reducing the required size of MPU RAM and faster boot time. The W77Q supports this by allowing direct, non-encrypted read access to boot code stored in the flash memory. This works in exactly the same manner as standard serial NOR flash memories. After it is committed, the firmware stored in the flash memory is protected by the cryptographic write protection function. This function protects platform firmware and critical data from unauthorized change. This assures firmware remains in its authentic state. Each write or erase command must be properly signed using a unique single-use key. Attacker cannot change firmware or data without knowing this key. The integrity protection and safe fallback functions are described in part 1 of this presentation and mentioned here for the completeness of this discussion. The integrity protection detects unauthorized change of code or critical data. Boot code integrity is automatically verified on reset. A failed integrity check triggers the safe fallback function for system recovery, which redirects execution to a fallback boot code. This operation is done by the internal mapping function and is entirely transparent to the MPU. Together, these two functions assure firmware state of integrity and authenticity is maintained over time and supports a path of recovery if needed. The W77Q assures boot code and other firmware is authentic and in a state of integrity. Authenticity is verified when the firmware is updated and committed. This is a verify once, use always scenario. The cryptographic write protection function assures firmware maintains its authenticity, and the integrity protection function assures firmware maintains its integrity. Together, these assure boot code is secure with respect to logical or remote threats. The W77Q Secure Serial Flash memory is introduced. It is a fully compatible drop-in replacement for standard serial NOR flash memories. The W77Q offloads security functions from the MPU into a single hardware solution, reducing the surface of attack, design effort, and required expertise. It is targeting remote and software threats, making it ideal for IoT security. Its key features include Platform Firmware Resiliency, secure over-the-air firmware update, root of trust, secure boot, and secure storage. Thank you for joining us. We hope to see you in the following presentations.